Okay, so far we've visited linear functions, and now we're again getting into absolute value functions. One of the things that we will start by doing, just like we did with linear functions, is graphing. So at the end of this lesson, you'll be able to graph an absolute value function. All right, we should have already gone through our absolute value stations, and so what I'm going to be doing on this slide is just putting everything together and describing what effect the different parts of the absolute value equation will have on the graph. So if you look at my general equation, it's going to be y equals a absolute value of x minus h and then plus k. And we're going to describe the effect of the letters on the parent graph, which is just the normal absolute value. So in the first one, this was referring to station 1, the a, the number in front of the absolute value bars, we found out that that affects the steepness of a graph. So I'm going to put affects the steepness, or affects the slope of the graph. And we also learned that if a is negative, a negative a will turn the graph upside down. So let's put turns graph upside down. Okay, now in station 2 we looked at h, and h was the number that was inside with the x. And if you can think about this, if it's inside with the x, it's going to affect the way that the graph is moving on the x-axis. And we found when we were looking at those that the h value is going to move the graph left or right. So I'm just going to put moves the graph left or right. And then we also found out by looking at the examples that it moves it the opposite of what we would think. So if this says minus 2, I would usually think that that would make me go left 2 because minus is a negative value and negatives are to the left, but it moves the opposite of what we would think. So I'm just going to put moves the graph left or right, and I'm just going to put opposite of what we'd expect. Okay, and then station 3 we were looking at the k. The k was the value that's on the outside. It's added or subtracted to the absolute value bars. And we found that that will move the graph up or down. Okay, and as we were looking at our examples, we did find that if this said plus 2, the graph moved up 2, and if it said minus 2, the graph moved down 2. So it did exactly what we expected. So I'm just going to put exactly what we expect. Okay, and I'd encourage you to continue going back to this page until you feel very comfortable graphing absolute value equations. All right, the next part says, how can you identify the vertex of the function from looking at the function rule? So I'm just going to give an example here. Let's say I have y equals 3, x minus 2 plus 5. Okay, the vertex is really pretty much where the graph has shifted, if it has shifted at all. And this one, the way that I can identify the vertex from looking at the function rule, this value right here, again, if I look at station 2, it's going to move the graph left or right, opposite of what we expect. So this minus 2 is going to move the graph right 2. And then the plus 5 on the outside is the k value. It moves the graph up or down, exactly what we expect. So this is going to move it up 5. So what that does to the vertex of 0, 0, it moves the vertex over to the right 2 and up 5. So that's how we will identify it, by looking at what's in with the x and then what's on the outside. All right, the next thing we're going to be doing is using the information to locate the vertex, and then we will graph the function. All right, so we are going to start with y equals 2, absolute value of x minus 1 plus 2. The first thing that I'm going to do is to try to figure out the vertex. So I need to figure out how the graph has shifted or moved. So I'm going to look at the number inside with the x, and I know the number inside with the x is going to make the graph move left or right, opposite of what I think. So if this says a minus 1 instead of going to the left one, I know that my graph is going to move to the right one, and I think I'll just write that down here. So it's going to move my graph right 1, and then the number on the outside affects up or down, and since this says plus 2, it is going to move my graph up 2. So if I'm looking at my vertex, I'm going to go to the right 1 and then up 2. So my vertex is going to be over 1, up 2. Okay, now the next part, I know that my graph is going to look like a V because it's an absolute value function. The number on the outside affects the steepness or the slope, so I'm just going to write this how we usually do a slope, which is rise over run. So from here, I'm going to rise 2, run 1, rise 2, run 1. And I'm going to go ahead and connect them. And then we do need to make a V, so I'm going to go back to the vertex, and I'm just going to go the opposite way. So I'm going to go rise 2, run 1, rise 2, run 1. And notice I now have my V, and I knew it needed to be a V because of the absolute value. All right, let's try another one. We have y equals negative absolute value of x plus 1 plus 2. All right, let's start in by the x. So I've got a plus 1 in by the x, and I know it's going to do the opposite of what I think. So it's going to go to the left 1. And then this plus 2, once again, is going to make my graph move up 2. So my vertex going to the left 1 would be negative 1, and then up 2 will be a positive 2. So I'm going to go to the left 1 and up 2. And then from here, if I'm trying to figure out that steepness of the graph, since there's just a negative there, that's really like a negative 1 in front of the graph, and then I will put a 1 underneath it. So the top number is my rise, and the bottom number is my run. Since it's negative 1, I'm going to go down 1, over 1, down 1, over 1, down 1, over 1, down 1, over 1. And that will go ahead and make half of my V. And then go back to the vertex, and we'll just go the other way. Down 1, over 1, down 1, over 1, down 1, over 1. And then again, I can finish my V. All right, let's try another one. On this one, I'm going to go ahead and look at what's inside. We'll notice there's only an x inside. There's not like a plus 5 or a minus 2 or whatever. So in the x direction, my graph is going to stay put. And then this plus 1, since it's on the outside, that affects moving up or down. And since it's plus, it's going to move up. So my graph is going to stay put, and then it's going to move up 1, and we'll notice that that vertex is going to be at 0, 1. And then my slope is negative 1/4. So again, this is my rise, and this is my run, and it's negative. So I'm going to go down 1 over 4, down 1 over 4. So it's a real wide graph. Now go back to your vertex and go the other way. Down 1 over 4, down 1 over 4. And then we've got our graph. There we go. All right, let's try one last one. I've got y equals negative absolute value of x plus 3. So once again, let's start with what's inside by the x, because that affects our left or right. Since this says plus 3, I know I'm going to do the opposite. I know my graph is going to move to the left 3. And then there's no number on the outside affecting us going up or down. So we are going to stay put going up or down. So we're going to go to the left 3 and then stay put. And so the vertex point is going to be negative 3, 0. And then from there, I do need to do the slope again. If there's just a negative there, that's like a negative 1. So I'm going to put negative 1 over 1. And that means I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. And then I'll just go back to my vertex and go the other way. Down 1 over 1, down 1 over 1, down 1 over 1. And we now have some graphs. All right, I'd like to do 2 more problems. This time we are given the graph and we just have to write the equation. So pretty much the same process, we're just going backwards. So the first thing that I'm going to do is look at, usually this is, the vertex is right at 0, 0, so I need to figure out what happened. This graph, the vertex, moved to the left 1, so I'm just going to say this graph moved to the left 1, and then it moved up 1, 2, 3, and then it moved up 3. So if I go to write my equation, we have y equals absolute value. The left goes inside, so it's going to be x plus 1, because we do the opposite of going to the left 1, and then up 3, we do exactly what it says. The last thing I need to do is figure out the slope. This graph goes up 1 over 1, up 1 over 1, so that slope is 1. So that would be my equation. All right, this next one, again, if I'm comparing the vertex of 0, 0 with my new vertex, this graph is going to move to the right 2 and then down 2. So I'm going to put to the right 2 and down 2, and that's going to help me write my equation. So I'm going to have y equals absolute value. Right 2 will make my inside say x minus 2 because I do the opposite, and down 2 is just what it says, so I subtract 2. All right, now let's just take a look at the slope. To do the slope, I start at my vertex. I'd have to go down 1 over 1, down 1 over 1, down 1 over 1. So my slope is going to be negative 1, and I have my equation. So hopefully now you can graph an absolute value equation.